Okay, so we're doing problem 2 of homework 6. So problem 2 asks us if we're given these identical independent random variables, what is the PDF if for this, for A, and then we have B, C, and D. So for A, it's x plus y equals z. So what does that mean? That means big F of z equals probability that z random variable is less than or equal to z, and we can just substitute the x random variable plus y random variable in here. So the probability of x random variable plus y random variable is less than or equal to z. And what is that? That's the integral of little f of xy dx dy over this area. So we can express this as a line. So we look at the inequality x plus y less than or equal to z, and we solve for y. So I move x over, we get y is less than or equal to minus x plus z. So what's that? That's just a line with a slope of -1 and y-intercept z. So I put z over here. We have the line here. It crosses the x. So when y is 0, we have x equal to z. So these are the intersection points for the x and the y. Now, because the PDFs over here are multiplied by the step function, that means that x random variable and y random variable cannot be less than 0. They're always going to be greater than or equal to 0. So that's why we're only concerned with y less than or equal to minus x plus z only in the positive quadrant. So when x is greater than or equal to 0 and when y is greater than or equal to 0. So that's why I only care about this shaded area over here. Because x can never be negative and y can never be negative because of the original functions. So now we come down here to find big F of z, so we can ultimately find little f of z. So big F of z is just this integral, as we wrote before, but because x and y are identical independent random variables, we can split them up into this. So this can become, this becomes little f of x times little f of y of y. So we just do that, and in the next piece here we write them in. So little f of x is e to the minus x, and little f of y is e to the minus y. Now I drew this picture to help me figure out how I want to integrate this shaded area. So first I'm going to integrate with respect to y. So I'm going to go, y goes from 0, y equals 0, to this curve. And this curve is y equals negative x plus z. So the limits for the integral for y is from 0 to minus x plus z. And then we integrate with respect to x. X goes from 0 to z. So that's why the limits are 0 to z. So now we carry out the integral. So I write the x integral from 0 to z, e to the minus x, because that's not affected by the y integral. The y integral gives us minus e to the minus x plus z plus 1, because it's minus e to the 0. So now I'm just cleaning this up here a little bit. We have e to the minus x minus e. I distributed the minus sign, so it's minus e to the x minus z plus 1. So now we multiply through. So that's going to give us the integral from 0 to z of e to the minus z, and I'm going to split it up into two integrals, dx plus 0 to z of e to the minus x dx. Okay. So now we just integrate normally. This is a constant, so we can pull it out. So we get e to the minus z, and then we get, oh, I missed a minus sign. There's a minus sign here. So there's a minus here. And then we get what? We get z minus 0 for this integral. here we have a minus e to the minus z, minus minus becomes plus 1. So we multiply through here, so we get minus e to the minus z times z. The 0 doesn't matter. Here we get minus e to the minus z plus 1. So I can pull out e to the minus z because it's a common factor. So I get, so I take out e to the minus z. I'm left with minus z minus 1 plus 1. Let's see. Right. So then, this is big F of z, but we want to find little f of z. So little f of z is equal to the derivative of big F of z with respect to z. So what's that? So we don't even care about the plus 1 because it's a constant. So we're going to look just at this guy. So we've got to use product rule. So product rule, let's take the derivative of the first one, which is minus e to the minus z times minus z minus 1, plus the derivative of the second one, which is minus 1 e to the minus z minus z minus, I'm sorry, this is not here. Just minus 1 times e to the minus z. So now what does this give us? Let's simplify it. We get z e to the minus z plus e to the minus z minus e to the minus z. So these guys go away, and we are left with z e to the minus z. And that is what our little f of z will equal for z greater than or equal to 1. So let me explain that. So we have f of z equals z to the e minus z, and this is for z greater than or equal to 0. So why for z greater than or equal to 0? Well, we know x is greater than or equal to 0, y is greater than or equal to 0, so their sum has to be greater than or equal to 0. And this PDF will be 0 otherwise. And that completes part A. So let me just